Welcome to section 1.2, row reduction in echelon forms. If you made it to this section, hopefully you have successfully gone through section 1.1 and feel pretty comfortable with those row operations. This lesson is a little bit more of the same, but we will introduce some more terminology. So this row reduction in echelon forms that we'll see today is a variation of Gaussian elimination. And this method that I'm going to show you applies to any matrix. And we kind of introduced this in the previous section, but what we're going to do is we're going to use those same three elementary row operations to make our matrix look easier. The leading entry is the leftmost non-zero entry in a row. So that's known as the leading entry. A non-zero row contains at least one non-zero entry. Echelon form, the definition is here. So all non-zero rows are above rows of all zeros. So here are some examples. I can read this definition to you, but I think it's easier to see it. So when you're looking at these examples, these are known as the leading entries. So these boxes here, because they're the first non-zero entry. And then the stars are basically any value including 0. These over here would be considered non-zero rows. And basically what we are looking for is this triangular pattern, a step-like pattern. And there's a little bit more to this definition here. So we want the leading entry in each row to be 1, which we kind of talked about briefly. And then each leading 1 is the only non-zero entry in its column. So that means everything below the 1 should be a 0. Okay, so reduced row echelon form, the leading entries are 1, and there are zeros above and below that leading 1. 5, this should say 5. So what we're going to be doing is the same thing that we did in section 1.1. We're going to use those 3 row operations. And now we are going to specifically try to put these matrices in reduced row echelon form. And to do this, we'll use replacement, interchange, and scaling. Now, the thing I want to emphasize is there is not one unique way of solving these. So the choices that you make to solve them will either make the problem more complicated or it will make it easier depending on what you choose. The thing you have to understand is that you need to practice these. When you are doing your homework, do the entire problem before coming up with the answer that you're just going to plug in. Okay? You need to practice this. And if you feel like the problems that were given to you in the homework was not enough, then find some more problems in the book. There are plenty of them, and practice. So what I want to remind you is that this entry here must be a pivot. Now we're asked to row reduce this matrix to echelon form. Okay, it doesn't have to be reduced row echelon form, just echelon form. So if I want that to be a pivot, I want that to be a 1. And looking at the other rows, I notice that this is a 1. So what I can do is I can interchange those two rows. So I will interchange row 1 and row 4. And when I do, I get the following: 1, 4, 5, negative 9, negative 7. Rows 2 and 3 remain the same. Negative 1, negative 2, negative 1, 3, and 1. And negative 2, negative 3, 0, 3, negative 1. Row 4 is switched with row 1 and becomes the following. Okay, now looking at this, this is a pivot. It's the leading one in the row. Now, if that is a pivot, everything below that must be 0. So if I want that to be 0, I'm going to start with this. I want this to be a 0. And if I look at that, what I can do is I can add these two rows together, and then that entry will be a 0. So I am going to take row 1, add it to row 2. This will become my new row 2. So row 1 is going to stay the same. It will be 1, 4, 5, negative 9, negative 7. I will get a new row 2 by adding row 1 and row 2. 1 plus negative 1 is 0. 4 plus negative 2 is 2. 5 plus negative 1 is 4. Negative 9 plus 3 is negative 6. And negative 7 plus 1 is also negative 6. Now, I also know that I want this to become a 0. So I'm going to kind of save myself a little bit of space. And I'm going to use the same thing, the same matrix. But now what I'm going to do is I'm going to take 2 times row 1 and add it to row 3. And this will become my new row 3. So I'm just saving myself basically a step from having to write this matrix again. So I'm going to have a new row 3 by multiplying this by 2 and adding it to here. So 2 times 1 is 2, plus negative 2 is 0. 2 times 4 is 8, plus a negative 3 is 5. 2 times 5 is 10, plus 0 is 10. 2 times negative 9 is negative 18, plus 3 is negative 15. This times 2 is negative 14, plus a negative 1 is negative 15. I'm going to leave row 4 the same because it has a 0 in that first entry. Now, this is great news because this is a pivot and everything below that is a 0. Well, now this is also a pivot. So everything below this must be a 0, and that's what we're going to work on now. So same thing as before. Now, if I want this 5 to become a 0, I'm going to use the row before it. I'm going to use row 2 and figure out what I need to multiply row 2 by so that when I add it to row 3, I get a 0. And what I'm going to do is I'm going to take negative 5 halves times row 2, add it to row 3 to get my new row 3. Okay, and then I'll do something similar for row 4. So let's go ahead and write this matrix. I will end up with a first row that remains the same, 1, 4, 5, negative 9, negative 7. The second row is the same, 0, 2, 4, negative 6, negative 6. Now row 3 is different. So I'm going to take negative 5 halves times everything here. So 0 plus 0 is 0. I get a negative 5 plus 5 is 0. Negative 10 divided by, negative 20 divided by 2 is negative 10, plus 10 is 0. Just keep trucking along and you will find that you get all zeros. Now we need to do the exact same thing for the fourth row. I need to make this entry 0. So I'm going to use row 2 again to make that happen. In fact, I'm going to take 3 halves times row 2 plus row 4 in order to get the new row 4. All right, and when I do, I get 0, 0, 0, negative 5, 0. All right, so let's analyze this a little bit. This is a pivot. This is a pivot. This is a little bit of a problem. I cannot create a leading entry in this. There's nothing I can do. It's all zeros. But this is a pivot. So what I'm going to do is I'm going to interchange these last two rows, because if I have a row full of zeros, I typically want that to be the last row. So what I'm going to do is I'm going to interchange rows 3 and 4. So I end up with the following matrix. Now, we have not been asked to solve this. All we've been asked to do is write this in echelon form, which it is, because everything below our pivots is 0. So what I want to do is, it asks us to find our pivot columns. So looking at this, this is a pivot, this is a pivot, and this is a pivot. So I have 3 pivots, and my pivot columns are 1, 2, not 3, and 4. And my pivots are 1, 2, and 5. Those are the values of the pivots. And this answers the question. Okay, here we go. We want to apply elementary row operations. And first we want this to be transformed into echelon form and then reduced row echelon form. So let's get started. Let's talk about what we know. We know that this first entry must be non-zero. Okay, so it doesn't matter if I switch this with row 2 or row 3. It's completely up to you. I don't know why, but I'm just going to interchange row 1 and row 3. Okay, so this is interchanging. There are a lot of entries in here, so when you are interchanging these, make sure that you check and double check your work. So we get 3, negative 9, 12, negative 9, 6, and 15. Row 2 remains the same. And then row 3 becomes row 1. Okay, now this is good news. This is no longer a non-zero entry. Okay, so we're going to keep trucking along. Now this is a pivot. It's the first non-zero entry. So remember, everything below the pivot must be 0. One of those is already 0. This, however, is not 0. So what I want to do is make that a 0. And the way I'm going to do that is I'm going to take -1 times row 1 and add it to row 2. This will become my new row 2. So row 1 is going to be the same. Row 2 becomes 0, 2, -4, 4, 2, and -6. Row 3 remains the same. Okay, so this is a pivot, and now this is a pivot. Everything below the first pivot is 0. However, that's not the case for the second pivot. Now what I'm going to do is I'm going to do everything I can to make this 0 because I need zeros below each of my pivots. So I need to think about what I can do to make that a 0. And I'm going to do something with row 2, add it to row 3 to become the new row 3. So think about for a moment what you would need to do to make that entry a 0. Hopefully you came up with taking -3/2 times row 2 and adding it to row 3 to get the new row 3. So rows 1 and 2 remain the same. Oops, I got ahead of myself. Okay, so now row 3 changes, and it becomes 0, 3, -6, 6, 4, and -5. Okay, that is not right. I'm sorry. That is, I just wrote the same thing. I'm sorry. It becomes 0, 0, 0, 0, 1, 4. I apologize for my error. Okay, woo-hoo. Let's analyze what we have here. Pivot, pivot, pivot. This is in echelon form. I know this is echelon form because everything below my pivots is 0, so it kind of creates that triangular form. This is known as the forward phase. Okay, but now we need to move on to the backwards phase, which is to get to reduced row echelon form. Okay, now remember, reduced row echelon form is I need the pivot to be 1. So to get to this, oh goodness, I need the pivots to be 1, and everything above and below the pivots needs to be 0. Okay, now to do this, it's often helpful to start with the rightmost pivot and work up and to the left, creating the zeros above each pivot. So everything below the pivots is already 0. Okay, so let's see what we need to work with. I'm going to go to the next slide just so I have some space. So I'll rewrite this matrix on the next slide. So here it is. Okay, now looking at my rightmost pivot, that is 1, which is great. Okay, so there's really not a lot I can do. What I'm going to try to do, however, is make this a 0. So if I want to make that a 0, I need to think about what I can do to achieve that. And the easiest thing to do is to use these 2 rows. So to make that happen, I'm going to multiply row 3 by -2 and add that to row 2. And this will become my new row 2. So row 1 remains. And row 3 remains. But row 2 changes. So if I multiply row 3 by -2, I get 0, 0, 0, 0, -2, -8. And then I'm going to add that to row 2. So I get 0, 2, -4, 4, 0, -14. Sorry, this is a little messy. Okay, excellent. Now what I want to do is I want this to be a 0. All right, so what I can do is focus on these 2 rows. Oops, oh goodness. This one and this one, and make that become a 0. So I am now going to take -6 times row 3 plus row 1, and this will become my new row 1. So when I do that, I have 3, -9, 12, -9, 0, -9. The others stay the same. All right. Now what I'm going to do is look at my next pivot. My next pivot is this. I need to make this a 1. And what I can do is I can just use the scalar. So to achieve this, all I'm going to do is multiply row 2 by 1/2. And this will become my new row 2. So this remains the same. Everything in row 2 I'm going to divide by 2. And row 3 remains. All right, so 2 of my pivots are 1. But now what I need to do is I want, let's see here. I need this to be 0 because everything above and below my pivots needs to be 0. So I need to make this 0. All right, so let's analyze these 2 rows here and see what I can do. Well, what I can do is I can take 9 times row 2 and add that to row 1, and this will become my new row 1. Excellent. So row 1 will become 3, 0, -6, 9, 0, -72. Row 2 remains. And row 3 remains as well. All right. Now what I want to do is I want this pivot to become 1. Make this 1. The way I make that 1 is I take 1/3 times row 1, and this becomes my new row 1. So I am dividing everything in row 1 by 3. So I have 1, 0, -2, 3, 0, -24, 0, 1, -2, 2, 0, -7. The last row remains the same. This is reduced row echelon form. If you notice, our pivots are 1, and everything above and below our pivots is 0. This is the backward phase of getting our item or our matrix into reduced row echelon form. Here, some more terminology for you. Once we have a matrix in reduced row echelon form, we will end up with what we refer to as basic variables and free variables. The variables that are dealing, or the variables involved in our pivot columns, those are our basic variables. Everything else is our free variable. And what we'll do is we will use this matrix and write a general solution that will basically be a description for all solutions. Okay. If the solution is unique, it will only have constants. If the solution is infinite, the solution will also contain some free variables. So let's look at what I'm talking about. Here is an example. So I've given you a matrix in reduced row echelon form. So let's identify our pivots. Here is a pivot, pivot, and pivot. Again, that's the first number in the row that is not 0. Okay, so these are my pivots. If I look at this row represents x1, then x2, 3, 4, 5, and 6. This is the right part, or to the right of the equal sign. Okay, so if I look at this, if there is a pivot, then that variable is a basic variable. So I have a pivot for x1, a pivot in x3, and a pivot in x5. Those are my basic variables. Anything else, my non-pivots, are the free variables. So it's basically everything else. Now, the reason I have these basic variables is those are, if I write my equations, they are not anywhere else in an equation. They're only located in one. So if I look at this, so if I rewrite this as an equation, I have 1x1, 2x2, no x3s, 3x4, no x5s, 2x6 equal to 4. Now if I look at this, x1 is only located in one spot. x3 is only located in one spot, and so is x5. Those are my basic variables. On the other hand, my free variables is everything else. So typically what we'll do then is we will solve for each of these. I'll solve for x1, so get x1 by itself. Get x2 by itself, x3 by itself, so on and so forth. And it will end up looking something like this. When I get So look at this here. When I get x1 by itself, I end up with this. x2 is a free variable. x3 looks like this. x4 is free. x5 looks like this. And x6 is free. Now, what it means to have a free variable is that you can choose any value you want. It's like a free space. You can make x2 be anything you want, x4 be anything you want, so on and so forth. Once those values are chosen, the remaining formulas can be solved. So, for any choice you make, for x2, you will get a different solution for the system. So that is why we refer to this as a general solution. It's a general solution because depending on what you choose for x2, you will get a different solution if your buddy chose something else for x2. Okay? We'll often use parameters in place of these free variables, and this is something that we'll get to later on in the chapter. A system is consistent if it has free variables, then it can have many parametric descriptions. Whenever a system is inconsistent, the solution set is empty. So there's not a parametric representation. Here is the theorem 2, which is stated here. You can take a moment and read through this. This here basically shows you the steps of using row echelon form to solve. And in this example, it says find the general solution to the system. So an example of a general solution was shown to you a few slides back, and that's when you solve for x1, x2, x3, and x4, and you may or may not have a free variable. So when we do this, when we find the general solution, the initial step, the initial process is the exact same. And again, the previous slide shows you what to do. So again, if I'm starting this problem, the first thing I want to do is write it in matrix form. So when I write this in matrix form, I will get the following. Check and double check that you have your matrix written correctly so that you don't make any errors down the road. I strongly encourage you to check your answers. Okay, now looking at this, I'm pretty happy because this is a pivot and it's already 1. So remember, everything below that pivot needs to be 0. So what I'm going to do is I'm going to begin that process. And what I'm going to do is I'm going to take row 1 and multiply it by 2 and add that to row 2. And this will give me my new row 2. So row 1 will remain the same. But row 2 becomes 0, 0, 3, 1, 3. Now I know that I want this to become a 0 also, so I'm just going to take another step here, and I'm going to alter row 1 and add it to row 3. So I'm going to take -3 times row 1, add that to row 3. And this will become my new row 3. So when I do that, I get 0, 0, -3, -1, 2. Excellent. Moving right along, I notice that this is a pivot. Looking here, I need to find my first non-zero term. That is a pivot, and so is this. but we're going to do one row at a time. If this here is a pivot, remember everything above and below that needs to be 0. So I am going to attempt to make this 0. And that's actually quite simple in this case because all I need to do is add row 2 to row 3, and that will become my new row 3. So I end up with 1, -2, -1, 3, 0. Row 2 stays the same. And row 3 ends up becoming, so I'm adding these. 0 plus 0 is 0. 0 plus 0 is 0. 3 plus -3 is 0. 1 plus -1 is 0. 3 plus 2 is 5. Huh. Oh my goodness. What in the world? Remember, we talked about this, right? This basically means that 0 equals 5, and we know that 0 cannot equal 5. Another way you can think of this is that the rightmost column has a pivot in it. If this is a pivot, that means everything to the left of that is 0. If the rightmost column has a pivot, there is a problem. It cannot happen. The rightmost column cannot be a pivot. Otherwise, you get 0 equals some number. Therefore, do you know that this is fancy for therefore? This system is inconsistent and does not have a solution. Okay, so if you find that the rightmost column is a pivot, there is no solution and the system is inconsistent. This concludes section 1.2.